everyone and a very warm welcome to Malhotra's IS Academy. This is going to be an interactive video. We are taking a topic which has revolutionized our lives. It affects our daily lives and I'm sure it is going to affect our lives even more in the coming years in a very positive way. So we are talking about the technology called optical fibers and specifically talking the use of optical fibers in communication. So what are optical fibers? Have you seen them? Have you heard about them? I'm sure you have. If you operate in an office or a home and you have some Wi-Fi facility connected with optical fibers, you must have seen colored wires like these. Or if you've visited a hospital or even heard about some treatments that hospitals nowadays are offering, you must have heard about endoscopy or very minor surgeries or just passing optical fiber inside one's body to see what is actually happening inside. As you can see in this picture, an optical fiber is passed and a camera is attached to one end of the optical fiber and a zoomed image can be seen on the monitor attached to it. Hold on, if you haven't seen any technical relevance or applications of optical fibers, you must have seen some decorative pieces. आपने कुछ ना कुछ decorations में देखा होगा जो कि ये प्लास्टिक की या ग्लास की पाइप्स होती हैं और एक एंड पर बहुत अच्छे से illuminate करती हैं. You must have seen such decorative pieces in your houses or around or in parties, weddings, functions, anything like that. So this is the broader relevance of optical fibers. They are around us, we see them every day, we use them every day, but their most important function is in communications. Now you and me, all of us know that in the past few years we have seen very high internet speeds as compared to few years ago. जो इंटरनेट की स्पीड्स हैं, डेटा स्पीड्स हैं, वो बहुत ज़्यादा बढ़ चुकी हैं एज़ कम्पेयर टू अर्लियर. इंटरनेट बहुत जगह पहुंच चुका है, इंडिया में ही कई इलाकों में पहुंच चुका है जहां पे पहले टेलीफोन फैसिलिटीज़ भी अवेलेबल नहीं थी. सो ऑप्टिकल फाइबर्स हैव अ मेजर रोल टू प्ले इन प्रोवाइडिंग दिस कम्युनिकेशन नेटवर्क. द रोल इज़ सो इम्पॉर्टेंट दैट द गवर्नमेंट ऑफ इंडिया हैज़ लॉन्च्ड a program called BharatNet or National Optical Fiber Network. We'll talk about this in detail in a while, but first of all, let's see what are optical fibers. Optical fibers है क्या, इनकी क्यों इतनी बात हो रही है, इनको क्यों इतना यूज़ किया जा रहा है और इन्होंने पुरानी टेक्नोलॉजीज़ को कैसे रिप्लेस कर दिया और किस प्रिंसिपल पे ये काम करती है जो कि पहले से ज़्यादा बेटर है. सो ऑप्टिकल फाइबर दो वर्ड से बना हुआ एक टर्म है. Optical in science, optical or optics in science stands for anything that is related to light. लाइट से जुड़े जो भी टेक्नोलॉजी होती है उसको हम ऑप्टिक्स के अंडर स्टडी करते हैं. ऑप्टिक्स में आप जो स्पेक्टिकल्स पहनते हैं या लेंसेज यूज़ करते हैं वो चीज़ें भी आती हैं. एंड फर्स्ट ऑफ ऑल दिस ऑप्टिकल इज़ रिलेटेड टू लाइट एंड द सेकेंड पार्ट फाइबर इज़ रिलेटेड टू अ ग्लास ट्यूब. सो बेसिकली ऑप्टिकल फाइबर एक पाइप की तरह, एक ग्लास ट्यूब की तरह काम करता है जो कि लाइट को एक कोने से दूसरी कोने तक भेजता है. सो ऑप्टिकल फाइबर्स दे वर्क एज अ ग्लास ट्यूब विच सेंड लाइट फ्रॉम वन एंड टू अनदर. सो बेसिकली जस्ट लाइक वी हैव वाटर पाइप्स विच कैन बी यूज टू सेंड वाटर फ्रॉम a municipal headquarters to your houses. Similarly, if we want to send light from one place to another, from Delhi to Mumbai or from Delhi to NCR, we can use optical fibers. So just like this, as you can see in the diagram, from place A to place B, this thing in black is a glass tube or it is called the optical fiber, and light can be sent from here to here. So this is the basic construction of your optical fiber. लाइट कैसे पास करती है ये हम अभी स्टडी करेंगे, बट उससे पहले हमें एक बहुत ही इंपॉर्टेंट लॉ जानने की ज़रूरत है. फिज़िक्स का बहुत इंपॉर्टेंट लॉ है. इट्स कॉल्ड द लॉ ऑफ रिफ्रैक्शन. सो लॉ ऑफ रिफ्रैक्शन इज़ वेरी सिंपल. वी लर्न अबाउट इट इन अ फ्यू सेकेंड्स एंड लेट्स सी हाउ लॉ ऑफ रिफ्रैक्शन हैज़ बीन यूज्ड इन मेकिंग optical fibers which have revolutionized our lives, which has revolutionized the way we communicate. So law of refraction basically just wants to say that you can have two types of mediums. Either you can have a rare medium or you can have a dense medium. Basically जो dense medium होता है जैसे कि solids हो गए उसमें particles बहुत close together होते हैं. Dense mediums have particles very close together while rarer mediums have particles far apart. So law of refraction says if light is passing from a rare medium to a dense medium, for example, if light is passing from air to glass, and this is the ray of light that we are talking about, this ray in red, and this line is the normal, ये perpendicular line है आपके इस base के साथ जो कि आपका medium boundary define कर रहा है. So this perpendicular to the medium boundary, if light passes from rare medium to the denser medium, then this ray of light, when it goes inside the denser medium, will go closer to this normal, which is the perpendicular line. It will go closer, it will bend towards the normal inside this glass slab. For example, if it is passing from air to glass, then this bending will happen and this angle will be actually bigger, and this angle, which is called the refraction angle, will be smaller as compared to the angle of incidence. So this is one part to it. The other part is, what if light is passing from a glass to air? Glass slab से air में pass कर रहा है, तब क्या होगा? So again we have this normal which is perpendicular to the base, and light is coming at some angle. Light is coming, this angle of incidence is there, and this is a denser medium, for example glass. So when it passes from glass to air, which is rare medium, light will not bend towards the normal now. Light will actually deflect from the normal, it will move away from the normal. Probably light has more space क्योंकि particles बहुत कम होते हैं rare medium में. Now light has more space to travel faster, so it bends away from the normal. Now what I want you to remember from here, from law of refraction, is this diagram. When light passes from a dense medium to rare medium, it bends away from the normal, so it moves away. Now let's see how this small law of refraction has become so important in our day-to-day lives. Let's move towards this diagram only, but in an inverted form. Here. So here what we have glass and we have air above. So this is your dense medium and this is your rare medium. This is your normal. If light is passing straight, it will go out. When light is coming from here at some angle of incident called θ1, when it goes into air, what will happen? It will deflect away from the normal. So this is your normal in red, and the light at this point, it will go away from the normal. This boundary, इस boundary पर away from the normal light चली जाती है, deflect हो जाती है. So now this line is very much tilted. It is very much tilted towards the horizontal. Let's try to increase this angle. ये जो θ1 है जो कि आपका ray of incidence का angle है, let's try to increase this. अगर इसको हम और tilted भेजते हैं तो ये light कहाँ तक tilt कर सकती है? There will come a point where this deflection away from the normal is so high, ये deflection इतनी ज़्यादा हो जाएगी एक point पर कि जो deflection के बाद ray of light आएगी, the ray of light which comes after the deflection will be actually parallel to the surface. As you can see here, this light, this angle is so big, this θc is so big that light passes parallel to the surface. You can see this here also. This light is passing straight. This is another diagram. Then I have tilted it a little bit and you see a bigger tilt here. Then there is more tilt in the third light and there is more tilt here. बहुत ज़्यादा bending है horizontal की तरफ. There is a lot of bending towards the horizontal line. Then again there is one point when the angle is so high that it bends towards, it moves parallel to the base. So this light, when it moves parallel to the base, refraction के बाद जब refracted ray parallel to the base हो जाती है, उस angle को हम कहते हैं critical angle. That is known as critical angle. Now what if I increase the incident angle beyond critical angle? Critical angle से भी ज़्यादा angle पे अगर हम light यहाँ से pass कर रहे हैं तो वो light ray कहाँ जाएगी refraction के बाद? Where will the light ray pass from after refraction if the angle of incidence is greater than the critical angle? Let's see. Here it was parallel. If angle is increased more, there are 110% chances that it will go inside the surface itself. तो जो लाइट आपकी ग्लास से एयर में जाते हुए बाहर जानी चाहिए थी वो एक्चुअली बाहर नहीं जाती, वो अंदर ही रिफ्लेक्ट हो जाती है. सो दैट्स वाई दिस कॉन्सेप्ट इज नोन एज टोटल इंटरनल रिफ्लेक्शन. Total internal reflection says that if your angle of incidence is higher than the critical angle as the name suggests बहुत ही critical होता है and it is different from all types of glasses. So अगर आपका incident angle उस critical angle से ज़्यादा है तो जो आपकी refracted ray जो कि बाहर जानी चाहिए थी वो actually अंदर ही trap in हो जाएगी. It will be trapped in inside that dense medium itself. And it will be, the light ray will be refracted inside the medium or reflected back inside the medium, as you can see here. This process, this phenomena in denser and rarer mediums is known as total internal reflection. This is one property. ये एक simple property है जो कि हम optical fibers में use करते हैं. Let's look at the diagram here. When you pass this light ray beyond critical angle, this light ray is coming actually here inside the medium itself and it is getting reflected inside. So now optical fibers just use this concept of total internal reflection. As you can see here, light ray passes here, the angle is more than critical angle and light ray gets reflected inside only. So this is one point of reflection. Again, when it strikes the surface of glass and air, this particular surface, the angle found here is more than the critical angle. So again reflection takes place, total internal reflection takes place and this ray of light is again reflected inside the glass tube only. And again TIR happens here at this surface and it goes on until infinite time. So what you can see from this first diagram is that total internal reflection was happening and इस process से हमने एक तरीके से light को कैद कर लिया है. We have trapped light inside the glass tube. So this glass tube has actually trapped this ray of light when it was trying to move from glass, that is denser medium, towards air, that is rarer medium. So now this ट्यूब ऑफ ग्लास हैज़ बीन यूज्ड एज अ पाइप. ये एक पाइप का काम करेगी जिसमें लाइट एक्चुअली काफ़ी एंगल्स पे टकरा के एक साइड से दूसरी साइड पर पहुंच जाएगी. सो दिस विल एक्ट एज अ ग्लास ट्यूब फ्रॉम विच light reflects at various points and it passes from one point to the other. This is what I was referring to when I was talking about this diagram, that it is a light tube. So optical fiber is a ट्यूब फॉर लाइट. इसमें हम ग्लास ट्यूब्स बनाते हैं. तो बेसिकली जो हमारे डेकोरेटिव इंस्ट्रूमेंट्स होते हैं, वॉट एवर वी यूज़ फॉर डेकोरेशन, वॉट इज़ हैपनिंग हियर, दीज आर स्मॉल ग्लास ट्यूब्स and light has been passed from one end and when it comes out at the topmost end, that end illuminates क्योंकि सारी light तो एक ही corner से बाहर आ रही है and this inside also you can see it lightening. So very beautiful effects are created and these effects, this particular property has been used in communication also. But to make communication very strong, there is some layering that is provided. हम glass tubes तो एक जगह से दूसरी जगह नहीं pass कर सकते. They will break down. They are highly susceptible to damage. So the optical fibers that we use nowadays, they have actually 3 layers. So inside layer, obviously here total internal reflection is being carried out. So this will be, formed out of glass. This green layer will be your core layer. Core layer के बाहर एक और लेयर होती है जिसका रिफ्रैक्टिव इंडेक्स, जिसकी डेंसिटी अंदर वाले ग्लास से कम होती है. सो दैट इज नोन एज द क्लैडिंग. क्लैडिंग हैज़ लेसर रिफ्रैक्टिव इंडेक्स दैन द core that is inside. So this system actually supports total internal reflection, these two tubes. Now to protect it, there is another coating that is added, that is the plastic coating or the buffer coating. So as you can see here, light ray undergoes total internal reflection inside this core. Then you have the cladding outside, and here you have the plastic coating. This is the plastic coating. Plastic coating can be of various colors. We saw it in the initial slides also. See, there are so many colors of plastic coatings. So plastic coatings basically durability provide करती हैं optical fibers को. So they add strength to the optical fibers, and optical fibers can be used to transmit light signals through hundreds or thousands of kilometers. You must have heard कि India ने अभी recently or India has recently laid down some undersea optical fiber cable, or near about your houses कुछ underground optical fiber cables lay down की गई होंगी. So that is being made possible because optical fibers have a lot of layers. So now we learnt about what is the principle of optical fibers and how they are used in communication. But ये लाइट को ट्रांसमिट करने का फ़ायदा क्या है? What is the purpose of transmitting light from one end to the other? We want electrical signals to go from one end to the other. For example, while using copper wires, electricity passes through copper wires, and that's how we used to talk at our landline, right? Landline phones हमारे copper wires से connected होते थे, and that's why we could talk to people because electrical signals were passed. Now, what is the purpose of light signals? कैसे scientists ने optical fibers की use को, light के use को communication में use किया? So let's see what is happening. For example, here you have electrical input signal in the form of a wave. This is the communication signal. For example, if you are talking to a friend, it is going in the form of electrical input. Here we have the transmitter, and here somewhere this electrical signal is converted into light. आपका जो electrical signal होता है, that is in the form of binary code. It is in the form of input data, which is in the form of 1010. So if you have where you have some information, that information is stored as a maximum in the form of 1, and where there is a low, it is stored in the form of 0. So this is basically an electric signal. This electric signal passes through a transmitter, then it goes to a light source where it is converted into light. वो जो light होती है, एक electrical signal को light signal में convert करके optical fiber से दूर दराज पास कर दिया जाता है. What is happening is electrical signals are converted into light signals by the use of these binary codes in the form of 0-1 language, and these light signals are passed through long distances. तो light के form में अगर signal जा रहा है, then optical fiber can be used, right? The signal in the form of light can be passed through optical fibers up to hundreds or thousands of kilometers. And जब वो दूसरे end पर receive किया जाता है, where you have the detector and the receiver circuit, here it is converted back into the electrical signal. So whether it was in the form of voice or video, whatever it was, it can be again converted into the output data, which is your electrical signal. Electrical signal में उसको वापस convert कर दिया जाता है. This is a very simple representation. Electrical passes through transmitter, and then it passes through optical fiber, which has total internal reflection taking place inside. Light ray here is trapped in the core of the fiber. Here you have the receiver जहाँ पे आपको information भेजनी है. At the receiver, light ray is converted back into the electrical output signal again, and hence communication can happen. आपका जो data transfer है, that can happen. Now we had copper wires functioning. हमारे landlines बहुत अच्छे से काम कर रहे थे कितने टाइम तक. We could pass electricity through copper wires. Then why this sensitive system was deployed? इंडियन गवर्नमेंट ने भारत नेट का प्रोजेक्ट क्यों शुरू किया है, या हम ऑप्टिकल फाइबर्स को लेकर इतने मोटिवेटेड क्यों हैं? द आंसर लाइज इन एफिशिएंसी. ऑप्टिकल फाइबर्स आर मोर एफिशिएंट दैन कॉपर वायर्स. वाई? बिकॉज जो आपकी लाइट वेव्स होती हैं, द लाइट वेव्स इन विच थ्रू विच ऑप्टिकल फाइबर्स आर कैरिंग इंफॉर्मेशन, they can have a very high frequency. Light की frequency बहुत ज़्यादा होती है as compared to the electrical signals that you are passing through your copper cable. So because the frequency of light signals is very high, means जो आपको frequency communication के लिए available है, the kind of frequency, the range of frequency you have available for communication, which we also call the bandwidth commonly बोलते हैं, and a spectrum is allocated by the government for communication in that bandwidth. So that bandwidth is very large. So earlier we could just transfer voice from one end to the other when we had these copper wires, but now you can send videos, you can make video calls, you can send audios, pictures, anything you want. In fact, we are shifting to 5G with the help of optical fibers. So optical fibers are more efficient, their bandwidth is higher, and copper wires जो होती थी उनमें signal loss बहुत होता था. There was this electromagnetic transmission that used to happen. तो energy loss बहुत ज़्यादा होता था, signal weak हो जाता था एक corner से दूसरे corner जाते हुए. But in optical fibers, efficiency is very high because light gets reflected from one end to the other. Pipe में light pass करना बहुत simple होता है. And at some point when we feel that the signal is becoming weak, it is very simple that you put a magnifier there or an amplifier there to increase the intensity of that signal. So optical fibers can be laid under sea. Say, we are connecting with Southeast Asian nations. Recently India has decided to connect Indian, south ports of India, lay down optical fiber networks in the Indian Ocean. तो आप इतना लंबा communication कर सकते हैं optical fibers के through, which was not possible in copper wires. See, this is an undersea cable. This is passing from a beach or from land into the water, and this is optical fiber inside the water. So whether you put it underground just like copper wires or you put it undersea, it can carry out light waves or in the form or electrical current converted into light waves. It can transmit signals through very long distances without much energy loss, as in the case of copper wires. So this is the reason why optical fibers are so important. This is the principle they work on. Now let me give you a brief picture about BharatNet. So BharatNet, basically Indian government recognizes that there are many rural areas, there are many gram panchayats which will be left behind or which are left behind from the progressive technology that is coming from time to time. So if you are sitting in a city, you must have heard about e-health services. आप video conferencing पे doctor से connect कर सकते हैं for seeking treatment, or you can attend your classes online, or just being able to watch this video online. But this internet connectivity is not available all around India because most part of the country comes under that rural India. So to bridge that gap, to bridge the digital divide in rural and remote areas and to bring them at par with urban areas, this is a project of government. It is called BharatNet or National Optical Fiber Network. Basically किया क्या जाएगा, 2.5 लाख ग्राम पंचायतें, there are 2.5 lakh ग्राम panchayats in India. All those will be connected through optical fiber networks or communication network. इसमें dark optical fiber use की जा सकती है. For example, if BSNL or any other PSU has already laid down optical fiber in a gram panchayat, then that will be brought to use. And there are many technologies that can be brought to use in such remote areas or such gram panchayats. So to provide broadband connectivity to these gram panchayats, to remote areas, a mixture of OFC, optical fiber connectivity, radio and satellite communication has been put in place, but optical fibers form major part of it. So in a few years, when all the gram panchayats are connected, hopefully we'll be able to bridge this digital divide, we'll be able to bridge this digital gap. BharatNet is the backbone of Digital India, and it is the world's largest broadband connectivity program for rural areas. So this was about optical fiber networks. Next time we'll see you with a video on how 4G networks or 5G networks operate, what are their applications and how can they be useful for India, and what are the major differences in all these kinds of technologies. So I hope this added to your knowledge. We are as a team always at your service, providing you with all the good quality content from time to time. Stay motivated, keep working hard, and we'll see you soon with another discussion.